Welcome to Louvain 1.2x. This course is a successor to Louvain 1.1x, the previous course. We assume as a prerequisite that you understand the concepts and also the notation of Louvain 1.1x, the Oz language, either by having followed Louvain 1.1x or by self-study. So Louvain 1.2x continues the story with three important topics. So first of all, data abstraction and state, and then concurrent programming, and finally, organizing all the concepts together in a coherent way in terms of programming paradigms. These are all essential concepts for programming in the real world. So the main theme of Louvain 1.2x is scaling up what we saw in Louvain 1.1x so it works in the real world. So the practical organization of Louvain 1.2x, so there are 7 lessons with homework exercises and a final exam. As before, the exercises will be done in the Mozart system and graded by our ingenious grader. So we will give a short introduction to these, but if you need a more full introduction, you have to go look at the introduction in Louvain 1.1x. Let me now explain the organization of Louvain 1.2x. So in terms of certificates, there's either an honor code certificate or a verified certificate. For the lessons, there will be 7 lessons, so 1 more than Louvain 1.1x, 6 lessons plus 1 bonus lesson. In general, there will be 1 lesson per week, but there are 2 weeks when we will have 2 lessons for the week. It starts November 17 and it ends on December 19 for the lessons. The exercises count for 50% of the grade. There are conceptual exercises, either multiple choice or fill in the blanks, and programming exercises where you have to write a program using the Mozart system and then submit it, and it will be graded using the ingenious grader. So the deadline is 1 week, but we will give a 2-week grace period for doing the exercises. And interesting, you have infinite number of tries. The final exam, which also counts for 50% of the grade, starts on December 29. So there's a break for end-of-year festivities there between the end of the lessons and the beginning of the final. And the due date for the final is January 12th. And be careful, there are only 2 tries for each exercise on the final, so think carefully before responding. So let me explain the schedule. So November 17, now the start of the course, we will have 2 lessons the first week. The first lesson on explicit state and data abstraction, and this logically follows onto object-oriented programming. Then the week after, November 24, we will continue the discussion of object-oriented programming by talking about the Java language and about interesting extensions, multiple inheritance, and exceptions for handling abnormal situations. And after that, we will switch to concurrency. December 1, we will talk about deterministic data flow. We will introduce the concepts. And on December 8, in lesson 5, we will give a number of programming techniques using deterministic data flow. So hopefully you will become proficient in deterministic data flow programming. And then the final week of lessons, December 15, there will be a lesson on multi-agent data flow. This is, in fact, the nicest all-round paradigm for concurrent programming that we know of, whereas deterministic data flow is the nicest paradigm in itself. It's not general enough to handle all situations for concurrent programming, but multi-agent paradigm is general enough, and so we figured we couldn't leave it out, so we had to add a lesson on that. And then there's also the final lesson, lesson 7, Paradigms of Programming Redux, where we will essentially take a step back, look at all the paradigms we've seen, fit them all together, see how they all fit together, and also look forward to how you can continue your studies after this course. So after that, there is a break, end of year festivities. You can have a good time and let the information sink in, and a little bit before the end of the year, we will start the final exam. But don't worry, you don't have to do it for New Year's. The end of the final is on January 12th. So the guest lecture, so the bonus lesson, lesson 6, is a lesson on multi-agent data flow programming. This lesson will be given by Seif Haridi. So this paradigm extends the deterministic data flow, which we will have seen just before, and you can add non-determinism exactly where you need it, but only there. So this makes it extremely powerful and yet also extremely flexible. So it is the best all-around paradigm for current programming that we know about. So this lesson will be given by Seif Haridi. So Seif Haridi, who's a close colleague of mine, he is professor at the Royal Institute of Technology in Stockholm, Sweden, and he's also chief scientist at a very interesting laboratory called the Swedish Institute of Computer Science. So the course textbook is the same as for Louvain 1.1x. It'll be Concepts, Techniques, and Models of Computer Programming by myself and Seif Haridi, published by MIT Press. So the same book for both courses. In fact, each course sees about 25% of the book. Both courses together, you will have seen about half of this book. So as for Louvain 1.1x, MIT Press makes available part of the book for the course, chapters 1 through 3. But in fact, this is not enough for the whole course. So we complement this by the slides, and I've also put in the course wiki a link to the last public draft of the book. So this public draft has all of the extra information that is not in the chapters 1 to 3. So with this, you have enough information to complement very nicely the lessons. Let me now talk about the content of Louvain 1.2x. So the overarching theme of Louvain 1.2x is how do we scale up the concepts of the simple paradigm functional programming. It's enough to write programs in any program you want, but it needs more to be able to realize programs that are in the real world. So there are several concepts that we will add. So abstraction is one of them. Data abstraction. This is an organizing principle, the main organizing principle that we will use to build very large software systems, large, complicated ones, millions of lines of code. And the real world is complicated, so programs have to be able to mirror this. We need programs that are larger than programs that could be written by one person. Teams of people have to be able to write them, and that's what we will use data abstraction for. The second concept, and an important concept next to data abstraction, is explicit state. And the reason why we need explicit state is to model change. Programs need to change. So a part of the program might need to be updated. The rest of the program stays the same. How do we do this? How do we model this? And this is important, of course, because the real world has change. So programs also have to be able to change. Parts of them change, parts of them don't. We have to be able to manage all of this. So explicit state is the concept we use for that. And then there is concurrency. So concurrency is a property of a system when you have many independent activities. Activities that are progressing independently that do not necessarily interact. So the real world, of course, is full of independent activities. We have to be able to mirror this structure inside of a program. And that's what concurrency is all about. But concurrency is actually quite complex to program in its most general form. So we introduce a simpler model called deterministic data flow. So this is a form of concurrency that always gives the same outputs for the same inputs. This is what we call determinism, and this allows us to simplify greatly how we program concurrent systems. So in Louvain 1.1x, we saw a first complete coherent paradigm called functional programming with its kernel language, with its techniques, higher order programming and so on, loops, invariance, recursion, and so on. Now we're going to build on that. We're going to see 4 more paradigms in Louvain 1.2x. These paradigms, each of them, will organize certain concepts into a coherent whole that we can then use to think about and build systems with. So in the first 3 lessons, we will see object-oriented programming. So this is a paradigm that is based on ideas from data abstraction. In lessons 4 and 5, we will see deterministic data flow. This is the simple form of concurrent programming that is so simple that we can program with the same good properties as functional programming. And then in lesson 6, we will extend this paradigm by adding what we call non-determinism where needed. So this turns it into a general concurrent programming paradigm. And because of the fact that most of your program can still be deterministic, can still use the simpler paradigm, and only a small part has to use the more complicated one, this is one of the reasons why this is the best all-around paradigm for concurrent programming that we know of. And then finally, in lesson 7, we will combine object-oriented programming ideas and multi-agent data flow ideas, because these 2 sets of ideas can be combined, and you can get the advantages of both in a paradigm called active objects. Now, let's start. So this first lesson, we'll talk about explicit state and data abstraction. So after this lesson, you will understand what it is that explicit state adds to functional programming. Functional programming is a general paradigm. You can program anything with it. It's what we call Turing complete. But something is added with explicit state. You will see exactly what it is in this lesson. You will also see how to build data abstractions. In fact, there are 4 fundamentally different complementary ways of building data abstractions for a given set of operations. You can package them and get 4 different ways of looking at it. Objects are only one of these 4 ways. So you will see all 4 ways, and you will see how some modern languages are actually taking advantage of more than one, but you will have the complete view of all 4. So this leads to the second paradigm, which in fact is based implicitly on data abstraction, and this is the paradigm of object-oriented programming.